Good morning and welcome to an IBM and Red Olive collaborative webinar where it brings me great pleasure to share with you how predictive analytics can provide significant savings for housing associations in a number of different ways. Just before we begin, I'd like to point you out to the question box at the bottom of the screen. Please can you, if you feel like you have a question throughout the webinar, please feel free to ask us anything that you'd like, and we'll come back to it at the end of the webinar to answer all the questions that you do have. And now I'd like to hand you over to Jefferson Lynch from Red Olive. Thank you.
Thanks, Tom. Well, one of the reasons we're running this webinar right now is because there's so much change happening within the housing sector. So we're seeing changes like the introduction of universal credit, bringing changes like direct payments to tenants. We're seeing changes like legislation such as the Localism Act, putting requirements on housing providers to demonstrate their financial viability and the need to demonstrate value for money, and a host of other measures. The COO of one housing association that I interviewed recently said that they were tracking the potential impact of universal credit as the #1 threat to their whole organisation. So I think it's fair to say there's an awful lot happening. So I think if you're working within the housing sector currently and you're feeling overloaded by the change level, then I think you could justifiably be forgiven. So in terms of the aims for today, what we want to do is explain how the combination of IBM SPSS Predictive Analytics software coupled with Red Olive's hands-on experience with organisations like yours can make a big difference. And we want to help you also to know what to do next and put in place an approach that will make a difference in your specific circumstances. So in terms of who your hosts are for today, my name's Jefferson. I've worked in the field of analytics now for about 17 years. I originally trained as a management accountant with Unilever, and my last role with them was as head of business intelligence for the European region. And I hope what I can add today is hands-on experience of helping lots of different companies get value from the data, particularly here in relation to modelling people's behaviour, which is what we're really talking about in avoiding arrears, and also in predictive asset modelling, which I've worked on particularly in utilities.
Hello, I'm Megan Williams and I work in IBM in SPSS Technical Sales and Solutions, and I'll be responsible for the demonstration portion of today's webinar. I'll be demonstrating some of what Tom and Jefferson will be talking about, and I'll be doing that later today. And I'll hand you over to Tom so he can introduce himself.
Hi, and I'm Tom Martin. I work within the business analytics area of IBM and specialise within SPSS, and I work across a multitude of different industries and sectors, helping many organisations with predictive analytics. Hopefully today I'll be able to share with you some of my experience and show you how predictive analytics could further benefit your housing association today. So I'd like to begin with IBM's slogan, really, which is game-changing decisions for all, or making game-changing decisions for all. So what does that mean? Well, people gather data and perform analysis manually or with tools that they have in-house, so that they can make decisions to drive their businesses forward. And sort of traditional tools to this date really have been able to make regular decisions to help drive their businesses forwards. However, IBM in the last sort of 5 to 10 years have really started to lead the forefront of innovation in regards to business analytics, and spent and invested a lot of money within this arena with acquisitions such as Cognos and SPSS, and really with one part of that being a leading BI tool. But now with SPSS giving that predictive element and being able to look at all time horizons. So something that I'd like to give you the image of is that if you were driving along in the car at this moment in time with normal tools, you can see everything in your rear view mirror that's happened before you, all of that old data, transactional data, and you can see everything up to the present as well. However, now with SPSS you can really start to predict what's coming up around the corner and make real accurate decisions. So with those products together, it gives you the ability to make game-changing decisions for the future. So now with the next slide that I'd like to take you on, I don't know if this looks familiar for yourselves or not, but in most cases when I show people this, that they go, yeah, no, it makes a lot of sense. And the reason being that I know there's a lot of words on the screen and it looks quite complex, and I think complex is probably the key word for this. But there's key points that I'd like to sort of highlight here. So there's complexity. Are you trying to make sense of all the data in different silos, bringing that all together? Then you looking at sort of gut feel. Are you making decisions today on gut feel rather than facts and true information that you have? Decisions. How do we make the best decisions with the best data and with the best precision available? Big data. That's a term that's sort of thrown out a lot at the moment, and quite a marketing term. But big data, the wealth of data is growing currently today, and the amount of data sources that we have is forever growing as well, especially with the emergence of social media, with Twitter and Facebook, and trying to get an understanding more of what customers and businesses and people are saying out in the World Wide Web, and also ROI. So the money that you're spending on these decisions today, is it giving you anything back in return? Are your tools actually providing the insight that you require? So this next slide really shows sort of how we can sort of help you to make more precise and more accurate decisions, which is another aim of IBM really, and coincides with that game-changing decisions for all. But really, as you can see here, there's four different circles: discover, predict, analyze, and decide. So it really, all of these circles should be interlinking to sort of complete a sort of a collection of best breed analytics capabilities. So as you can see from here, so you've got discover and visualize, report and explore. So visualizing the problem areas that, for example, understanding which tenants have fallen into arrears, and to be able to report on this and to explore the reasons why that's happened. But then they're moving over from discover into predict, and being able to predict who's next, which tenants are the next likely people to fall into arrears because of the same segment or demographic information, or showing the same traits that people within discover are already showing. Then going forwards and then looking at decide, to be able to understand what to do next, and to really put actions upon that or strategies to try and turn these people around, and then analyze those, see if those KPIs have been met that have been set by sort of senior board members, and also see if those goals have been achieved. I know that with a lot of housing organisations, customer satisfaction is something that you want to sort of strive for. So this is something that could be monitored within those, and then the circle kind of always goes round with these four circles. And now I'll hand you over to Jefferson Lynch, who will tell you a little bit more about Red Olive.
Thank you, Tom. Well, so who are Red Olive? Well, we're a UK-based consultancy, and we specialise in analytics and data management. And so I mean things like predictive modelling, data visualisation, data warehousing, those kind of areas. We actually work in lots of different sectors, and that cross-industry learning is a strength that we look to bring to help housing associations. We're also an accredited IBM analytics partner, and particularly in the area of predictive analytics. And we aim to conduct business in an ethical way, and that's part of the reason that we were approached last year about working with housing providers. So what are we aiming to cover today? Well, first a quick introduction to analytics as a whole, then how to avoid arrears, particularly in light of the increased risks we've mentioned already as being caused by universal credit. Still on a financial theme, we'll move on to fraud prevention, and then switch to look at driving value for money and reliability from predictive asset maintenance. And then finally, we'll look at the value that you can obtain from combining that maintenance data with contact center call details.
Thank you, Jefferson. So now it sort of leads me on to why analytics, and really the reasons for analytics because of the challenges facing organisations today. So firstly, addressing the analytical needs of a business user. So 1 in 3 business leaders frequently makes decisions based on information that is either incomplete or unreliable. So based on a recent study by MIT and IBM Institute of Business Value, it's clear business leaders frequently make decisions on information they don't trust or don't have. So how do we satisfy the analytical needs of non-technical business users who who are in the front line making key decisions on a daily basis? How can these individuals who don't have the time or skills leverage analytics that are simple but yet powerful? Secondly, exploiting value from a relevant new mix of data. So by 2015, 80% of the world's data will be uncertain, sort of due to origin or authenticity. We all know that data is exploding and becoming far more uncertain than ever before. We know this data is critical to our businesses in many different ways, and how organisations harness this information for insight and value is the most important factor. And how can you combine the relevant mix of data to get answers to your business's questions? How can I deal with the size, the variety, and the uncertainty of that data? And lastly, making decisions at the point of impact. Top performers are 2 times more likely to use analytics to guide operations and future strategies. And this is through sort of improved and optimized business decisions through using analytical techniques such as statistics, modeling, algorithms, machine learning tools, data mining, and it gives your organisation a deeper understanding of your unstructured and structured data to allow you to make game-changing decisions or further game-changing decisions that you weren't able to do before. So this takes me on to my next slide, which is what is predictive analytics. And predictive analytics helps connect multiple different data sources, such as your attitudinal data, such as social media data from Twitter or Facebook or blogs, or even sort of other attitudinal data sources such as customer satisfaction surveys, and combining it with information such as payment history of tenants and their sort of demographic or segment information as well, and bringing that all together to create sort of effective action by drawing reliable conclusions about current conditions and future events upon the past data. And I thought this was quite a nice sort of start to the SPSS and predictive side of things, and it really leads on to the 3 key areas that we work within. The first being customer analytics, which is all around acquiring, in this case could be acquiring new tenants, growing the existing tenants that you have throughout the lifetime of them working with you, and also retaining tenants that you want to keep within the organisation, and identifying those customers or tenants. Secondly, operational analytics, understanding how to manage your assets more efficiently, maintaining them, not just sort of scheduled maintenance, but getting away with that, making it more predictive, sort of doing maintenance that's needed at the right time rather than doing unnecessary scheduled maintenance which you might be carrying out and costing you a lot of money today, and maximising that infrastructure that you have already. So in this instance we work with a lot of water organisations, and quite a nice sort of case study where what we do is we take a lot of data from the depth of where the pipes are buried, the type of material the pipes are made out of, when they were buried, and how long ago they were, and by that we can predict where the next blockages or burst pipes are going to be. So you can start to predict that and get those pipes fixed before that happens and creates more problems for your organisation. So that could also be related to maybe boilers or roofs or cavity wall insulation within the housing association. And then lastly, threat and fraud analytics really is around sort of monitoring, detecting and controlling. It can be within multiple different instances, but in this instance today we'll be looking around the entity analytics side of things, so being able to detect your tenants that move around the housing association undetected. So people that might fall into arrears and then move to another part of the housing association without you realising it. So we're going to show you that a little bit later as well. And what also you can see here below in the diagram is really different ways of accessing and starting to play with that data and getting real insight from it. So we've got SPSS statistics, SPSS Modeler, SPSS Analytics Server and Catalyst, and SPSS Scoring and Decision Management. So we'll be covering SPSS Modeler today. Some of you on the call might know about statistics and how that all came about previously. In terms of Analytics Server and Catalyst, that interacts with Hadoop, and decision management is really around business users that aren't analytically minded being able to type in questions to sort of understand for example, typing in which tenants are most likely to fall into arrears next, and it will bring up and score it for them without having the use of an analyst to do that. And then, of course, BI to be able to visualize that and do reports upon that. And now I'll hand over to Jefferson to tell you a little bit more around the problems within the industry.
Thanks, Tom. Well, as I mentioned earlier, the moves by the UK government to pay tenants directly and also to pay monthly rather than weekly are a big change that's causing anxiety for a lot of people. Now, potentially the biggest losers here are actually the tenants themselves, particularly if they get themselves into debt and then end up unable to pay their rent. Just to give you some idea of the scale of the problem that I think we're talking about, some of the housing associations that we've been speaking to have estimated that they're likely to get a rise of between 4 and 10% annually in arrears, and that's off a base of 0.5% roughly today in many cases. So if we work at the bottom end of that range and assume let's say a 3% rise, so a relatively conservative number, then if you're working in a housing association today where your annual revenues, your income are about £50 million, let's say, that means a likely rise in arrears each year of about £1.5 million. So that's £1.5 million of extra cost potentially for your housing association. Based on experience, or our experience in several other sectors, we've been able to make significant decreases in bad debts by working with customer service groups, for example, and debt reclamation teams. And we have every confidence that that should be achievable for each of you as well, if that's the problem that you're facing today. And the way we do that is through building a number of predictive models, hence why we're on this webinar, using SPSS Modeler, and we'll be looking at that in more detail later. If you want to understand more about the process that we go through for doing that, then there's a link that you should be able to see at the bottom of this slide. You'll be able to get a recorded copy of this webinar later, so you can use that, or please do feel free to give us a call. Okay, so the next two slides show an overview of some important points in the life cycle of a tenant, and also why it's important to act quickly if what we think is someone's likely to get themselves into debt. So in other words, with the time window we've got between potentially seeing someone as a risk and then becoming a problem for us is relatively short. We need to act quickly. So what's shown on this diagram, on this slide, is the behaviour of two tenants. So tenant 1 and tenant 2, one above another. There's a timeline running from left to right, and these two new tenants are both arrived. They're both new to the housing association, and they go through the same process of sign up, of initial visits from a housing manager, of other initial contact, perhaps by the phone as well as face to face. And to start with, they're both paying regularly. That's what the little green arrows pointing down are showing you. And then tenant 1 carries on that way, and eventually, just in the course of things, they move again, perhaps to a different part of the country, and they stop being a tenant. So it says here that they leave of their own accord, and there's no problem at all. Tenant 2, at a particular point in time, starts to get behind on their payments, so they miss the first payment, and that's what the red arrows are showing you. And then, as it will be the normal process, they're sent a series of advice letters, but that doesn't address the problem, and ultimately they end up in the terrible position, the sad position that actually they're evicted in this case. So the key question for us is there any way that we can tell before this happens that someone is becoming at risk and is at a high risk of default, and can we take some action early to avoid that default happening at all? So potentially, can we identify someone before they get into any debt, or at least can we act quickly so that they don't get to a level of debt that they just can't recover from? Well, I'm pleased to say that the answer in many cases from our experience elsewhere is yes. We can identify those people. And what this slide is showing is some of the potential intervention points along the tenant journey that we've just had on the previous slide. I hope you can see the overlay there. So right at the application stage, it may well be that there are certain personal attributes that we can pick up perhaps from their application form that are important enough to make a difference and to identify that someone is at a higher risk perhaps of getting into a default position. And one of the things we found from our work in utilities as an example is that where we've had older people perhaps living by themselves, and if the situation was that they had stopped paying their bills or they weren't paying their bills, often they needed to be handled quite differently from many other groups of people. And let me explain why. What we found in some cases was that certain people in those circumstances, the reason that they weren't paying an estimated usage utility bill was actually just that they didn't understand that because it was estimated it still needed to be paid, and as it wasn't just a piece of post for information, that it needed to be acted upon. So they were able to pay those people. They were willing to pay potentially, but it looked to us at the moment like they weren't willing to pay, and actually there was an education issue that needed to be done. Because the bills were misunderstood and then they were ignored. Simply sending a reminder didn't help, but clearly the way that you would look to respond to someone in those situations, or the way in those situations where you would want to, is quite different from someone who is refusing to pay, or potentially who can't pay. So what we've looked at so far is relatively static factors, things that we can know about someone at the start of a process, but very often that's not enough. And that's where predictive modelling really comes into its own. And based on behavioural history, that's where we start to model. So often a change in behaviour can be an early warning of what's about to follow, and so that's where early interventions can be taken. So risk can be flagged, and then something such as a quick phone call can be introduced rather than a letter, for example, or rather than just not acting quickly enough. So these predictive models can help flag those people who are at highest risk, and then allow us to act exactly where the work is needed quickly. Just as a quick aside, this is exactly why entity analytics that Tom's going to be talking about a bit later on is so important, and it gives you so much more, because it gives you so much more history to learn from. So potentially, rather than having someone who's arriving cold as far as you're concerned and where you have no behavioural history, potentially by identifying that person as the same one that was either in your own or another housing association and had previous property, again we can identify whether those people are perhaps vulnerable to falling into debt. Okay, so I've just moved on a slide, and really I'm just going to cover this one quickly, but this is a schematic of a typical solution to handle the type of situation that we've just talked through. So very briefly, on the left hand side, we at the bottom, what we generally do is we take all the potentially useful data sources, and from those we extract the data that we want to use for predictive modelling, and we put that into a structured and analytical database. And then we create a set of predictive models. Typically we'd be using SPSS Modeler rather than SPSS statistics, and they're shown up on the left hand side here in yellow, the yellow nugget, and I've mentioned here a few potential ones. So it may well be that we start off with a segmentation model, for example, to look at people's attributes, and we may well then build a number of different arrears models based on those different people segments. Just moving on from there, what happens is we identify then as a result a set of people who are at highest risk of falling into debt, and so those at the bottom right, which says list of tenants at risk. And what we're then looking to do is put in place some kind of intervention, and we've just talked through some of those. And then top right is the visualization, typically for whoever's managing that whole process of outcomes and interventions, so you can actually see what's working and what isn't. Not clearly shown on here, but what happens in practice also is that there's a feedback loop very often from so the interventions that are at the bottom right into the different source systems we identified over on the left hand side. So what can happen over time is your models can get tuned, and again that's why it's very helpful to have the dashboarding capability up on the right there. And on the next slide here, what I've done is, again, I won't go through this in detail now. I know Megan will be looking at this much more during the demonstration, but I just thought it was worth trying to bring to life. This is a screenshot taken from SPSS Modeler, and what it's showing is exactly how we go about doing the things I've just outlined to you. So again, you can have a look at those at your own leisure, but connecting to a data source, so getting hold of the data that we wanted from the sources, and so on, and actually building the models is all done in this one interface here. Okay, so just to recap on the arrears prevention solution and approach we just talked through, this is a great place to start making a real difference. You can make a real difference to your tenants through the models that we've talked through and developed here. And as I hope, and as you'll see more from Megan later, using SPSS Modeler reduces your reliance on statistical knowledge as well. And I'm going to hand back over to Tom.
Thank you, Jefferson. So back to my, I was talking earlier, back to the three pillars: customer analytics, operational analytics, and threat and fraud analytics. So this is really on that threat and fraud analytics side of things. So entity analytics. Really, this came about due to having a meeting with a housing association, and this problem was a big one with them, to be honest. So what they couldn't do is they couldn't detect multiple entities that were moving around the housing association after they'd fallen into arrears, and then moving into another property of theirs, and just creating them more and more money that they were losing. So in this instance, as you can see, we've got Bill Smith and we've got William R. Smith. So on the right with William, he was arrested in 2013. So this is more of a sort of an insurance or sort of police looking record, but they both lived in 123 Main Close. The phone numbers are very similar. They both have very, very similar national insurance numbers as well, and they have the same date of birth, even though the numbers are slightly different. But because they're all slightly different, it's sometimes very hard to track if it's one person or two different people. So I'll take you into this in a little bit more detail now. So what is entity analytics? So if all your data consisted of a single source of records that were complete and unambiguous, it would be really easy and relatively simple to read through the data and perform your processing and obtain reliable results. However, in the real world, the picture is usually very different. Data is typically far from complete, frequently ambiguous, and often scattered over many different data sources, recording many different attributes with few overlapping fields. Quite often, individuals are not recognised as the same person, or entities are inaccurately associated with combining data from various sources. A further challenge is when individuals intentionally try to mask who they are and what they're doing with different names and addresses as well, because they understand how they can get around and sort of be ambiguous within a housing association. Entity analytics provides organisations with the ability to be more accurately to accurately recognise and identify entities, whether they are individuals, also vehicles and vessels, and resolve conflicts prior to statistical and predictive analysis. In fact, the more data there is to analyse and the more diverse the data sources, the better the results, which in turn improves the accuracy of predictive modelling. So better data sources could be those attitudinal data sources, such as Twitter and Facebook social media, on top of their demographic, transactional and previous registration history as well. The ability to resolve entity conflicts is crucial for industries where the quality of data needs to be as accurate as possible, and the predictive model's accuracy is critical. Areas such as border security, fraud detection, money laundering, criminal identification are areas that immediately come to mind. But this is also so specific for housing associations. This is also useful for improving customer relationship management and ensuring you're not sending duplicate marketing offers to the same person because of data that he or she has not been cleansed properly. So then moving onwards, this is sort of a real life sort of example of how this has happened in the past. And as you can see at this moment, this person is Elizabeth Lisa Johns, and she's applying for a loan, but please relate this to your housing association. Maybe she's applying to become a tenant, and her details listed. So and her application details are listed on the screen. So she currently has no claims to have, and she claims to have no previous defaults, and has a debt to income ratio of 17.3, as you can see there on the screen. Now, if our loan policy or ability to accept her as a tenant was to approve those applications, there was it shows that there was no previous default history and the debt income ratio was below 25, we would take her on. So, however, by using entity analytics, we discover there are two existing records within our data with variations. So these two here, and the names, addresses, phone numbers and date of birth, financial details and income all vary and differ, but as you can see, Elizabeth Johns matches with Liz Johns, but also matches with Beth L. Johns. The same with the phone number, they also match with these two records, and the date of birth matches with record 102 and record 642 as well. So with the use of entity analytics, it matches these types of information to actually identify that this is actually the same person. So we can now use this combined information to deduce that Elizabeth actually is not a good applicant for the housing association, and this is actually her resolve entity, and you can now see that she's defaulted on her payments, etc. So this is how I would show you how to sort of check who are good tenants for your housing association, new people that you want to acquire and take on, and people that you don't want to do so. So now this takes me on to the area of the webinar, which is predictive maintenance or predictive asset maintenance. So what is predictive maintenance? Predictive maintenance is understanding the patterns in operational data to determine the areas of greatest risk and directing resources before risk becomes a reality. So the predictive component of predictive maintenance stems from the goal of predicting future trend or asset condition. Predictive maintenance is a form of predictive analytics with particular concern about operational data, as to opposed to the data associated with individual customers or people. In particular, predictive maintenance is focused on behaviour of assets or equipment within organisations, and we can think of it as a way of trying to understand patterns in operational data and associate them with those of assets, so we can determine greatest area of risk associated with the performance and direct resources to those assets before risks become a reality. So we're very strong here at SPSS in terms of predictive maintenance within multiple different industries, and how we can use predictive maintenance to help you as an organisation for example, we've got finding patterns in maintenance operations that could point to opportunities for improvements. So, for example, 5 years after installing a boiler within one of your housing associations in one of your properties, if it was installed in a certain area with a certain water type, and it's a specific type of boiler, it might be used to, or there might be the signs that boiler breaks down due to limescale build up or something along those lines. So you can start to predict those kind of factors to manage and maintain those assets before that happens. Then there's identifying assets at risk of failure even when they have no previous history of doing so. This is all about understanding the realms of data that you have, and the more data that you have, whether it's call center notes, whether it's engineer logs or subcontractor logs such as carpenters or electricians, or the environments that your assets are within. Identifying factors that increase ownership cost and downtime over the life of a system. So, for example, cavity wall insulation, being able to lower the heating bills for a property, but by doing this, keeping tenants happy at the same time. So, being able to log and pull together different data sources such as customer satisfaction and transactional values, as well as environmental factors. So, for example, bringing in the customer satisfaction, the customer's not very happy at the moment currently because the boiler's breaking down. So with regards to transactional, they're not paying their rent and falling into arrears, and environmentally the house isn't as performing as it should be. So by upgrading the boiler, this all came from talking with another housing association, upgrading the boilers and making their houses more energy efficient, they were able to put strategies in place for the tenants to then pay their arrears going forwards. So there's lots of application areas, as you can see, around predictive maintenance, but I am also very aware that I'm running out of a little bit of time, so I'm going to move on to try and get towards the demonstration. So where asset maintenance can be applied for your housing association. So to predict and identify opportunities for operational efficiencies in asset management, increase safety and increase environmental sustainability. So very similar to what I was talking about in terms of understanding your assets conditions, such as the boilers, maybe insulation, whether it be roofing, could be solar panels, increasing that environmental factors for the future, but having those strategies in place to do so to increase the amount of money over a certain amount of time. Use predictive analytics to identify when equipment in the field is likely to fail or need maintenance. So getting away from planned or scheduled maintenance and replacing it with predictive, and very much in terms of inventory management, which is used quite a lot. So if you've got a lot of spare parts or spare equipment and tools, etc., that you're holding because of all of these planned and scheduled maintenance procedures that you have, maybe doing away with some of that because you can predict actually the usages and the needs for the properties instead of spending money on procedures that they don't need at that time. And now I'd like to talk a little bit around call center analytics in improving tenant experience. So Woonbendrift. Woonbendrift are a housing organisation in the Netherlands with 31,000 residents properties and 70,000 people. What they wanted to do really was look at the behaviours and different segments of their customers and their tenants, and by analysing large volumes of data, their text data from call centres and surveys and other realms of attitudinal sources such as social media, they wanted to really get an insight into what their tenants were saying around Woonbendrift and the properties that they're living in. I feel that this is a nice case study to quickly finish this off and pull these aspects together, because it really does pull in the areas where you've got customers talking about, or tenants talking about, the housing associations, maintenance of the properties, what they really thought, the service that they're getting, and by making it a customer-centric organisation, it really gave them some good benefits in terms of being able to increase the accuracy of targeted communications and strategies by sort of capitalising on market segmentation insights. It also increased customer satisfaction by pursuing customer-centric practices and enabled them to be more transparent and through gaining customer insights. And also streamlined operational and maintenance processes by following a preventative maintenance approach based on the analysis of historical service order patterns. They're having a lot of problems in regards to logging engineer notes with what people were saying in the call centres. So what would happen is somebody would call in and say, I've got a problem, and this is hypothetical, with my boiler. There's water going everywhere, and the call centre wouldn't quite understand exactly the requirement and send out a chippy instead of a plumber. And so you can understand the customer satisfaction getting lower, but also the problems that the housing association was having with paying for bills of subcontractors, which they didn't need to. So now I'd like to pass you on to my colleague Megan Williams, who will take you through how this all now works in practice with IBM SPSS Modeler.
Thanks, Tom. I'm now going to give a demonstration on how you can use IBM SPSS Modeler to do such things as predict which of your tenants are likely to fall into rent arrears and predict which of your properties are likely to need maintenance or repairs. But before I do that, I just want to introduce you to the IBM SPSS Modeler interface for those of you who haven't come across it before. So on the right hand side here is where you can organise your analytical project into using the industry standard CRISP-DM method, from business understanding all the way through to the deployment of the models you created. You can swap between the streams you're using, look at any of the outputs you've generated, as well as selecting any of the models you've generated during your analysis. At the bottom here you have all of the nodes available to you in performing your analysis, from source nodes that will give you access to the data, through to record and field operations that will help you with your data preparation, graphs and output that will help with the data understanding and evaluation of the models, and then modelling nodes that will allow you to build the predictive models. These range from automated models that will run and compare a wide range of models for you, through to the specific models such as classification, association and segmentation models. You can then export these out to a number of different in a number of different formats, from exporting back to a database, into a flat file or an Excel file, through to exporting into Cognos BI itself. And then the main area you see here is where you build the streams themselves and perform the predictive analytics. So now we're going to begin and build our first stream to determine which of our current tenants are likely to fall into rent arrears, so we can put in preventative measures. So to do this, we're going to bring in a range of different data, ranging from tenant demographic information, which we have in an Excel file, so things such as the age of the tenants, their gender, and the number of people in each house, through to information we've gained from a recent survey as to the satisfaction level of our tenants, which we have with either satisfied, dissatisfied or neither nor. Then we're going to bring in some information about the financial state of our tenants, so how much they earn a week, how they pay us, is it by direct debit or is it in cash payments. This is in another Excel file. And finally we're going to bring in any information we have about whether or not our tenant has fallen into arrears. So this is the historic data we're going to use to be able to build our predictive model. So we know previously who has fallen into arrears, and we're going to use this to predict which of our current tenants are going to fall into arrears. So the first thing we need to do is combine these data sets to form a single view of our tenants. So one data set that contains all the information, what we're going to do is connect them to a merge node and merge them together based on the tenant ID. So this is a common variable that's in all of our datasets that identifies the variables to the specific tenant, so we can match the tenant demographic information with the level of satisfaction. What I'm going to do is just preview to see what our end dataset is going to look like. So you can see the tenant ID at the start, followed by the demographic information, all the way across to whether or not the tenant is satisfied with their current housing, and then across to the financial information such as how they pay us, is it direct debit or cash, whether or not they're on housing benefits, and then finally whether or not they've fallen into rent arrears. So the next thing we may want to do is look at how many of our tenants have fallen into rent arrears. So we're going to look at the distribution of that variable. So we connect up a graph node and select arrears and create the graph. This is just a nice simple graph to show us that 4.8% of our population have actually fallen into rent arrears compared to 95% of our tenants who haven't. So it's just a nice way to see what the current state is and what we would be looking to reduce in the future. So in the future we would expect less of our tenants to fall into rent arrears because we would have spotted those likely to and put our preventive measures in place to stop that from happening. So we've done a bit of data understanding, and now we want to do some data preparation. So this includes telling the SPSS Modeler what we're trying to predict, what we want to use as predictors, which variables we think are going to be indicative of whether or not someone's going to fall into rent arrears, and which variables we want to exclude from the analysis. So we're going to exclude the tenant ID as well as the form of tenancy, because this is a duplicate variable, and as well as the day and the month that the tenancy started, as they're not very important predictors. And then finally at the bottom we're going to set the whether or not someone's fallen into rent arrears as the target, as that's what we're trying to model. So next we're going to select the model we want to run. In this case it's a chained decision tree, and what you'll notice is the moment we connect it up to the stream, it automatically knows what it's predicting because we told it what to predict in the type node. So we're now going to open up the modelling node, and as you can see all of the exclusions we made in the type node have followed through. So everything we excluded is over here on the left. All of our predictors that we selected as inputs are over here under predictors, and our target is being pre-selected. There are a number of options you can do to customize the model, but what we're going to do today is just run the default. So this will create a modelling nugget which will contain information about the model and the model itself. So as we created a decision tree, this creates a list of the rules that the decision tree uses, as well as tells us the most important predictors. So in our case, the most important predictors include the overall tenant satisfaction, whether or not a tenant receives DSS payments, the number of beds within a property, and demographic information such as the age of the first tenant. So you can see that these predictors have come from all of the data sets we included, which is why it's always useful to include as much data you have available to you when building these predictive models. So now I'm going to move over and show you the output of the decision tree. So this is what a decision tree looks like, and you can follow the branches down to determine how likely a specific group of tenants are to fall into arrears. So that's what I'll do now. So if you start at the top, you can see whether or not someone receives DSS payments is a very big differentiator as to whether or not they'll fall into rent arrears. So if they do receive DSS payments, 16% of those are likely to fall into rent arrears, which is a lot, which is a high percent considering we started out with only 4. So this may be a group of tenants we want to target going forward with preventative measures. We can look at another group of tenants here. This group has 12% chance of falling into rent arrears, and to find out the rules that generated this node, or who this tenant or who would belong to this group, you follow the decision tree back up. So this group of tenants are people who don't receive housing benefits, who are either work as a student, unemployed, or work part-time, and who are overall satisfied with their accommodation, and who don't receive DSS payments. So this could be another group you wish to target with your preventative measures, whether this be calling them to discuss their rent situation, or maybe a leaflet campaign with information on how to avoid going into rent arrears, whatever options you have available to you within your housing association. So that was just a brief overview of the decision tree, and now what I want to do is look at how good this model is. So what we want to do is connect up an analysis node to see how much we're predicting correctly and how much we're misclassifying or predicting incorrectly. So we can see that this model has predicted correctly 95% of the time, which is actually quite a good model. And what we also want to see is what's actually been added to our data. As when creating the model, it's actually added two columns. One that's the predicted whether or not they're full into rent arrears, and the other column is the predicted likelihood of whether or not they're full into rent arrears. And this column is probably going to be the most useful going forward. You're going to want to select those with the highest likelihood of falling into rent arrears to target with the preventative measures. So that's what we're going to do now, is build a deployment stream looking at our current tenants and seeing who is likely to fall into rent arrears in the near future. So we're going to create a new stream for this, for our deployment phase of our model. So we've got our model, we're happy that it's accurately predicting who's going to fall into arrears, and so we now want to score our current tenants to see who we should be targeting with our preventative measures going forward. So we're going to bring in our data on our current tenants from an Excel file and load this in as we did previously, and then we're going to again tell the software what we're looking at by using a type node, what we're going to be using as inputs going forward. And this time we don't have a target, as we don't know whether or not these tenants are going to fall into arrears, as they're our current tenants. And what we're going to do is bring in our predictive model we just made in our other stream and connect that up. And then we're going to connect a table to see what it's doing to our data. So similarly as it did in the other data set, it's going to add two variables to the data set, whether or not the tenant is going to fall into arrears and the likelihood of whether or not a tenant is going to fall into arrears. So you've got those two variables again at the end. So what we may want to do now is sort our tenants into, so we have those who are most likely going to fall into arrears at the top of our data set. So we can then pull these out into an Excel spreadsheet and distribute them throughout the business to our teams who will be contacting them. So what we're going to do is bring in our variable that we want to sort on, and then we want to sort in ascending order. So this will leave us with the tenants who have the highest likelihood of falling into rent arrears at the top. We then may want to take a sample of these tenants and include the first 100. That's who we're going to target with our campaign to prevent them from falling into rent arrears, and export this into an Excel spreadsheet so we can distribute this across our enterprise. So you just locate where you'd like to save this, and we'll call it our target. What we've done is exported an Excel spreadsheet containing 100 of our tenants who are most likely to fall into rent arrears, so we can target them with preventative measures. So now we're going to look at another stream that that I've created that does a similar process, but looking at predictive maintenance of your assets. So in this case, looking at which properties need to have repairs completed in them. So in this case, we've done a recent inspection of several of our properties and determined which ones them needed repairs or maintenance to ensure that they're up to the standard we need our properties to be at, and also to ensure that our tenant satisfaction is high, as they're not living in properties that have damage. So in a very similar situation as to our previous stream we just built, we've brought in our data and merged it together and created one view of our properties. So what I'll do is I'll run the table just so we can get a feel for what our data set looks like. So again, we've got the tenant ID, as that's how we determine our properties, looking at the type of property it is. Is it a flat? Is it a house? The number of beds within a property, but then also looking at the total number of children and adults currently living in that property, through to the number of repairs that have previously been done, as well as the age of the property, the area in which the property is located, and the number of days since the last property check, all to determine whether or not a repair was needed for this specific property. And what we really want to be able to do is predict which properties we want to go in and inspect next, as which ones are likely to need repairs, as it's often the case that if you catch a maintenance issue early on, it's going to cost you a lot less than if you catch it further down the line. So this could be something as simple as seeing that the mastiff in the bathroom is leaking, and replacing that before it causes a much major problem within the bathroom. So once we've brought the data in, again, we're going to use the type node to tell the data what we're predicting, in this case whether or not the property needed to be repaired or have any maintenance work completed. And then in this time we're going to use an automated modeling node to select the model we're going to use. We don't really know which one's going to work best this time, so what we're going to do is run the automated model. This will create a different model for each of the models we selected, and then test them against each other and decide which are the top three. So our models have all been created and compared, and we can now look to see which was our top performing three models. So we see that they're two decision trees in the decision list, and shade is the most accurate, and so that's the one we'd use going forward. What you can do is click on the model to find out more information about it. In this time we can have a look at the decision tree that was created. It seems whether or not a property is going to need repair will depend on the area in which it's located, and then if it's in area D or E, it will then depend on the age of the property. If the property is under 15 years old, it will then look at whether or not what tenancy agreement is in place, and if it's a starter tenancy, it will then look at the property age and determine whether or not if it's older or if it's older than 8 years, it will have a 7% chance of needing repairs. You can see that this varies. There are some nodes that have a 45% chance of needing repairs, and these may be ones you want to go and inspect to try and catch those maintenance issues early to save yourself the money that leaving these problems can cause, and also to increase the satisfaction with the tenants. If they're living in a well-maintained property, that they're more likely to have high satisfaction. This is just one example of the type of predictive maintenance you can do. Quite a simple example. Depending on the information you have, you may want to look at predicting boiler maintenance, whether when boilers are going to maybe fail and stop heating the house or producing hot water, because this can often happen usually at the worst time of year when it's absolutely freezing, and this can cause very low tenant satisfaction if they're living in a very cold house with no hot water for an extended period of time. But by being able to predict when it could fail, you can put in preventative measures and do preventative maintenance to ensure that the boiler is going to be functioning for as much of the time as possible. So again, we want to look at how good our model is performing. In this case, it's at 83% accuracy, and this may not be the best model, but for the uses we're using it for, we're quite happy to go forward with this as our model. We're then going to attach the new repairs or the houses that we're considering for inspection, initialize it with a type node again, run it through our repair model, and what I'll do is I'll select the table node so we can see the output again. Again, it's very similar. You have a yes or no whether or not the house is likely to need repairs and the probability of the house needing repair. You can then sort and select the most 150 properties likely to need repair or that should be inspected next, so you can determine those maintenance issues and plan accordingly with your resources, as well as to ensure that your tenant satisfaction is increasing or is staying, or your tenants are staying satisfied. So they were just a couple of examples of how you can use IBM SPSS Modeler to help predict both predictive maintenance of your assets for things such as repairs, boiler maintenance, and other maintenance issues you may have within your housing associations, but as well as predicting things like which of your tenants are likely to fall into rent arrears. So these are just a couple of ideas, and I'm hoping that you'll be able to see the usefulness of this within your organisations and other examples where you can use it that I haven't said today. I'm now going to hand back to Jefferson, who will close the webinar.
Okay, well, thank you, Megan. Well, we hope you've enjoyed the formal part of this presentation and that we've been able to show you how working with IBM's SPSS software and also an experienced partner like Red Olive can help you improve your tenant experience and protect your cash flow and also foresee likely maintenance problems. We're now going to open up the floor to your questions.